Okay.
Okay, so we did a RCC turning steering servo.
So each piece of the motor is made out of either a plastic or a metal piece, like bronze and steel. There's 4 main gears that it runs off of a brushed electric motor and is all controlled mainly by a potentiometer. And the gear ratios of the 4 gears that you see here in the picture are based for like a torque application.
Here's the sketches we did of all the components.
And then our continuity test, both of the items that we did were could pass electricity through them since they were metal, and then the brush motor, which was one of the components that we did, actually would activate if you placed the continuity piece on certain areas of the motor. The material test, it's very magnetic, or the metal test, it's very magnetic, and both of them are, considering they are made out of metal, and then the motor itself actually has a magnet inside of it in order to run, so that made it also really magnetic. The nail that I used didn't scratch either of the 2 components at all. And then the mass of the brush motor was about 39.5 grams, and the second drive gear, or the other, or one of the gears that we used, was about 1.4 grams. And you can't bend anything with your hand. So,
Yeah, so here's the 2 Inventor pieces we did, just one of the gears and the small brush motor.
the mass of the brush motor ended up being about 0.087 pounds, and its volume was around 0.312 inches cubed, and its surface area was about 3 inches. The second drive gear was had a mass of a little over 0.03 of a pound, and its volume was a little over 1 inch, and its surface area was actually really small, even though it's a decent sized gear.
Here's the multi-view sketches. Some of the dimensions are kind of hard to see, but that was the brush motor.
And then here is the second drive gear, which also a lot of the dimensions are difficult to see.
Most of the pieces are plastic and metal, so you can recycle a lot of them and use them to make other different projects as shown below.
So you can have like robotic hands and different stuff like that. And then we also did an additional component, which was the potentiometer itself. And the shaft of the potentiometer is connected to the shaft of the servo, allowing it to kind of recognize what position the servo's in. It rotates with the servo also as another form of knowing where its rotation is. And then its angle corresponds to different resistances that the potentiometer creates, and the controller is able to know the exact angle for reading that. And this picture below kind of gives an instance of what the potentiometer in the steering servo looks like. So, thank you very much.
All right.